She wanted to know if I'm ready. I'm not sure I'm ready, but we're ready. Rima may or may not be with us today because she's the only librarian here. So as soon as somebody comes in for some books, she's going to vanish. And remind me before you do that, how do I find those pictures? What do I do?
You know, if you want, we could start with them showing up right now.
Yes, why don't we do that? Okay, good deal. And then if I just
oh, I know what I did wrong.
All right.
I've already forgotten.
We are still struggling with technology here. Rima is very good at it, and I am totally ignorant with it. All righty. So that first one with the tropopause.
Yes.
Which one
Where
is
did it
that?
go?
Come back here. Out of the cloud, right? Which is suitable for our program. When we get started here in a minute or two, we are oh, that's pretty good. Oh,
Good.
it's that's good. That's good.
Okay.
Now, is there some way to raise it up a little bit or not? So we can see the tropopause, basically.
You know,
okay,
this little thing.
That little thing. Well, we'll just pretend that that's not there. Okay,
That's in a crucial spot.
That's good now. Yeah. Okay. Before we get started, Rima, is this unusual weather or what?
Yes, very.
Very. We're talking about in the next 4 months into fall through the winter. I think we're going to end in the end of February. We're going to have about 9 programs on the weather. Everything you ever wanted to know, sort of, about the weather. And I must admit, and you must admit, it's absolutely crazy this November we've been having, where the grass is still green and growing. Don't put your mowers away. We're going to have to do at least one more mowing before the snow comes, if it ever comes. I was reading an article by a agriculturist who's a scientist, and he mentioned something that I guess I knew, but it didn't register. We're in an El Niño female year. And when that happens every 5, 6, 7, 8 years, we on the northeast part of America tend to have longer, warmer autumns. And that is definitely what we're having.
Oh, yeah.
My lettuce is still growing like crazy, and the beets and the carrots and the radishes and whatever. What do you have in your garden still?
Kale and lettuce.
Kale and lettuce. All righty. So
That's pretty happy.
It is happy. It's perfect weather. Around 40 at night, in the 60s in the day. Perfect. Except we don't have enough rain.
Yes.
All righty. For those of you that are new, now listen, do you know if anybody's tuned in that we have to?
That's why I keep looking at this.
Okay.
I'm going to tune myself in.
Okay, she's going to tune herself in on her desk computer. So if somebody wants to tune in late, you can join in, and I'm just going to chatter on. Before we go anywhere, I want to clarify the difference between weather and the climate, because people are forever mixing them up. So it's really quite simple. And before I go there, I want to just kind of mention to folks, because most people don't think about this. We live, most of us, right on the earth, right on the ground. And we are living at the bottom of an ocean of air. It's like if you were a fish and a flounder lives on the bottom of the seafloor, and above the flounder is all that water. Well, we live on the surface of the earth, and above us is all that atmosphere, that air. Now, all of the weather that we experience, almost all of it, 98%, happens in this lower layer, the troposphere. And it's interesting. 60 years ago, when I was in high school, the whole US was going to switch to the metric system, like the rest of the world. We never did. And so when you get scientific information, you tend to have it in meters and kilometers and grams and centigrade. And we are still living in the past with our strange measurement system. And so sometimes I have to translate. And sometimes these figures over here on the left column aren't exactly the same book to book. So I'm going to say our troposphere basically goes up about 30,000 feet or so, 6 miles. If you're on the equator, it's a little higher. If you're up at the North or South poles, it's a little lower. But on the average, it's about 30,000 feet, in spite of what that says. Those of you that have flown in jets know all the bouncing around that makes your heart go, ugh, happens in that first 30,000 feet of the troposphere. Once if it's long distance, like from here to Los Angeles, once the pilot gets up to 30,000 feet, all of a sudden it's as smooth as can be. And you're looking out the window and all the clouds, all the weather is down below you. And that's because basically there's no weather, there's no humidity, no moisture, no rain, no clouds up in the stratosphere. So that's, I think, interesting to know. Now, what's weather? Well, those of you that listen to the weather report, what are you interested in? Rima, what are you most interested in when you turn on the weather report?
Right now, the temperature.
The temperature? Why right now, the temperature?
So I know what to wear to work, so I don't freeze or...
Okay, she wants to know whether to take the umbrella, put on her boots, cover up the left before she left.
Right.
She's gonna freeze.
Wear multiple layers.
Okay, so she's interested in the temperature. What else are we interested in? What'd she get?
It's gonna come roaring.
Oh, she just turned on the heater because it's so warm outside. It's warm inside. We don't need the heat on yet, even though it's November. Okay, temperature, precipitation.
Yeah, I was just gonna say, yeah.
Is it going to be snowing? Is it going to be raining? Is it going to be sunny and beautiful? And what's a third thing is what? We don't usually.
Humidity?
Humidity, absolutely. And there's something else called air pressure, which helps organize all these things and allows one or the other to happen in your particular spot on the earth. So that's what we're going to be studying over the next couple of weeks. What is the weather? What kind of precipitation? How humid is it? What's air pressure got to do with anything besides creating wind, which is the movement of air? I always think it's interesting. Sometimes when you work with kids, kids are fascinated with the cloak that makes you invisible, right? But everything that's around you in this ocean of air is invisible, right? Because I can see right through it. There you sit. There's nothing in between you and me, right? Until the wind blows. What is the wind? If not air moving past you. And then you feel it. Still can't see it unless there's dust. But okay.
Or leaves.
Huh?
Leaves.
Leaves on our mind.
Yes.
Alrighty. Now, going back to my original point, which I sidetracked from because I had to, give a foundation here. Weather is simply, make sure I get this right. It's day to day and it's local. And I'm going to give two beautiful examples of this. I live on a hill about 4 miles out of town. I'm about 400 feet higher than the village of Alfred, or 1,000 feet higher than either Wellsville or Hornell. In the summertime, you can have a thunderstorm that's very localized, and I can have an inch or two pour down on me, and down here in the village, it didn't rain a drop. Okay, that's local. I had another experience years ago when I worked at the tech. The forecast had called for some snow, a lot of snow. We hardly ever had snow days at the tech. I was teaching. So I got up at 8 in the morning and there was like 2 inches of snow on my hilltop. And it's 3.5 miles down into the village. By the time I got to the parking lot at the tech, there was 8 inches of very heavy, wet snow, and they'd close the school.
Wow.
Because they hadn't plowed anything yet. It was a very, very heavy snow and 8 inches deep. So that would probably be like 24 inches of dry snow. So I turned around and went home. That's an example of local weather, right? You look out the window and you see what it's going to be for you, where you are. Now, climate is totally different. Here we have something like a federal agency. I don't know what they're exactly called, the Weather Service, something or other. And our taxes help pay for them. They take a 30-year average. So what was the weather every day for 30 years? So that goes back 1990 to 2020. And they average it out for a region, a large area, maybe even an area 1,000 miles across. Now, I kind of looked at the map, and I think we fit in the Great Lakes region here in Allegheny County. We're not New York City. Hi, Regina. We don't live right on the ocean. They have a different climate down there in the eastern part of the state. I'm assuming the Adirondacks have more of a Canadian or a New England climate because they're higher elevation and they're further north. But we in Western New York are really part of the Great Lakes system. Okay, so the interesting thing about climate, I'm a gardener and I've been here for almost 40 years gardening. And so I'm aware of changing in patterns. And so when I first moved here, we were in zone 4B, which meant that at least once or twice or 3 times in the winter, the temperature would drop to about 25 below.
Wow.
Wow. Yeah,
I remember that.
But in 2020, when that 30 years new band, they dropped off the 80s, started with 90 up to the present time, including the last 10 years, and things had changed. We now had shifted up into zone 5A, I believe it is, 20 below. Now, and what that did, that shift of half a zone, gave me, the gardener, about 3 weeks average growing season between frosts, which is quite a lot.
That is, yeah.
Quite a lot. So climate is 30-year average, and it's the region. And let's see, what does that say? Yeah, I think I mentioned it all. What's this? Okay, I went over the local weather and the Great Lakes. Let me just, now this is kind of like an opening talk. So we're just touching on things which will go into deeper as the weeks go by. But in our Great Lakes region, anybody that's lived here for a while knows that once November comes, usually, I look out the window with the blue sky, usually in the old days, November came and the clouds came. And it was 80% cloudy all the way through the end of March, 5 whole months without a lot of sunshine. So that was part of our regional climate. The other thing was, we all know the lake effect snowstorms coming out of Buffalo, off of Lake Erie, down off of Lake Ontario. It was interesting is that Alfred was at 90 miles away, driving, probably 70 air flying. We were at the very edge of that. Well, we'll go into why that is. And my prediction, write this down, check it out over the next 10 years. In spite of global warming and less snow, the folks who have ski resorts in the snow belts toward Buffalo are still going to get a lot of snow. And we'll talk about why later in a month or two, whenever we talk about that topic. All righty, what's happening here? Oh, and the other thing is, for us, the winds tend to come out of the west.
Yes, mine does.
Once in a while, northwest in the winter, once in a while, the southwest in the summer. Very rarely from the east. And once again, later on, when we talk about wind patterns, we'll talk about why that is.
Yeah.
All righty.
I remember when I was a little girl here, the snow came, I was probably 60 years ago. The
Yeah.
snow was over the top of our door.
Yeah.
Go outside.
Well,
The tunnel.
the snow always, when I built my house in Elmwood in the 70s, the snow would always come out just around time for a voting, that first week in November. And it was covered ground, no bare ground, till the end of March. And then it still snowed once in a while in April or even in May. Yeah, well, those days are gone. All righty. So we talked about region. Let me think here before I move on. Let's look at the next map. Where it showed North America and the oh, that was good. Okay. Oh, very good. Here we go. I love maps. All righty. Before we talk about this, let's think about a balloon. You roll up a balloon and you tie it off. Inside that balloon is a mass of air, right? And it's contained. It's an air mass. If we burst the balloon or open it up, that air mass can dissipate. So let's think about over our heads in that ocean of air. It's not the same from California to New York, hardly ever. There are different air masses, and they're much bigger than just a balloon's volume. Maybe I should pause a minute. I think everybody knows, but maybe doesn't think about it. Gases and liquids are amorphous. Unless something holds them in, they just float away, or the water seeks its own level.
Yeah, flows.
Okay, so they're fluid, both gases and water. So when we're talking about an air mass, it doesn't stay consistent as if it were inside of a balloon for very long. However, by definition, each air mass, depending on where they started from, their birthplace, has usually the same temperature, give or take 1 or 2 degrees, the same humidity, and they exist at the same air pressure, partly because of those two things. The temperature and the humidity will affect the pressure. So let's look at the map now. And we have more than we're going to talk about because we don't live up in Oregon or down in California or up here in the Maritimes in Canada, or down here in the Southwest. We have 2 large air masses that affect our weather. And one originates up somewhere, maybe in Alberta. And I'm sure you've heard on the radio once in a while, the Alberta Clipper. It's usually in winter. And it's a cold front that comes through where the temperature maybe plunges 30 degrees within a few hours, clears off. And we have a few days of really cold blue skies, 10 below at night. Okay, that's a continental polar air mass. It originated over a continent, so it's relatively dry. In a polar region, it's relatively cold. Okay, versus this little devil down here in the Gulf of Mexico, a maritime tropical. It originates over the water. It's going to be humid. It's tropical. It's going to be hot. And this is what tends to float up the Mississippi, up the Ohio, and into Western New York in the late spring and summer, and brings all that hot, humid weather. And once again, we never had in Allegheny County years ago. Allegheny County was like this in the summertime. 60s, low 70s in the day, 45, 50 at night. Relatively dry. So anyway, those are the 2, the continental polar and the maritime tropical, that usually affect our weather.
The polar, is that coming over the mountains?
Not necessarily. Come right down out of eastern Alberta, which is high plains, over Manitoba, what would it be, Montana, the Nebraskas and whatnot. Yeah, so it tends to, not mountains. Okay. All righty. Let me see where I'm at page 2. Where is it? Okay. Do we have that beautiful example you found of the water molecule and the
Yeah.
crystals?
Who do you want first?
The water molecule.
There.
Cute.
Yes. But he's saying, oh,
Oh, water. Yes. Okay. Now, we're going to talk about, what are we talking about here? The atmosphere, which is the ocean of air. And I think most of you, somewhere along the line in school, learned that what we're breathing is about, so I'm rounding off, 70% nitrogen, which is basically inert. About 29% oxygen, which is what gives life on Earth. We need it to breathe. Plants give it out. Okay. And then that leaves roughly 1% of everything else. We're not going to talk about the teeny tiny things like argon. We're going to mention 2 things, and we're not going to dwell, at least now, on the carbon dioxide, which everybody's been hearing about these days, but water vapor, the H2O water that's in a gaseous form. We're going to call it vapor. Now, it's only, we have to do a little bit of math. I'm not going to do a lot. This is mainly qualitative weather reporting, not quantitative. But every now and again, I'm going to have to sneak in a few numbers because science speaks in the language of math. That's just the way it is, folks. But I'm going to make it easy. 0.001, a teeny tiny percent of the atmosphere is water vapor. Now, what's 0.001? I came up with a wonderful analogy, I think it is.
10,000.
Well, let's say first you divide it into dimes and then pennies. You have 100 pennies, right? Make a line, 100 pennies. That last penny, you slice into 10 parts. You pick up one of those little parts, 1/10 of a penny compared to the $100 bill. That's of what in the atmosphere.
I'm really surprised about that. I would have thought of that a lot later.
yeah, me
Yeah.
too. In humid places, especially.
No,
No.
not, this is average over, you know,
Polar.
yeah. So yes,
Oh, places.
think of all the polar places.
But-
Third,
Or the desert.
And there's
that's
more
more.
tropical than desert. Don't you think?
Uh-uh.
Oh, I would.
We'll look at a map next time when we talk about climates. You're gonna have to hunt up climates. Let me think for a minute now. My wonderful analogy. What was I? Where were they going with that? Oh, I think that is a perfect example of how people say, let's go to let's pick on Cleveland 40 years ago. Oh, it's just a little bit of industrial waste. You tossed it in the river. What was it, the Cuyahoga River? Well, we all know what happened to the Cuyahoga River in the 70s, right? What happened?
It was on fire.
It yeah,
Burst into flame. I don't
burst into
remember what happened exactly.
right. Or the ocean. So there's a couple of particles floating around the ocean.
Yeah.
Or think of the germs, the tiny, one little germ, and it can kill you. So just because it's 1/10 of a penny compared to 100 pennies doesn't mean it doesn't necessarily have a big effect. And I think that's something we are now learning with global warming and the amount of carbon dioxide in the air. Much up there. What is everybody worried about? All right. Now, Rima,
Yes.
you went hiking in the Rocky Mountains, right? How did you go? We talked about this a few days.
I can't remember. I just remember that I kept seeing signs. We kept seeing signs saying that the air was getting thinner and be careful. And if you feel faint, don't keep hiking.
Okay.
I was surprised because I felt fine.
You have a good oxygen ratio and good lungs, I guess. You don't smoke, do you?
No.
Yeah, good. Okay. Probably you didn't go higher than 10,000 feet. One of the big Rocky Mountain parks north of Denver is about at 10,500 feet. And I've been at between 7 and 8, and I start puffing. If you go 18,000 feet, like Wolf did on Mount Kilimanjaro years ago. I think Mount Kilimanjaro is about 18,000 feet. And you get, what is that called? Something sickness.
Oh, yeah.
Altitudes.
Altitude sickness. Yeah, yeah. So anyway, at 18,000 feet, if we went back, don't do it, but if we went back to our tropopause map, you've now at a level where oxygen's 1/2 of what it was down at sea level. So of course, most people are huffing and puffing at 18,000 feet.
So what fills the space that the oxygen is not occupied?
The air is less dense. It has dissipated because the air pressure is
It's
less.
still in the same proportions. It's just not.
Yep.
Okay.
Let's back up on the same proportions because I'm not sure about that. I'm guessing. I think nitrogen is. I used to be a chemist. I used to know this. If nitrogen is denser, has more atomic numbers than oxygen, then the lighter elements tend to float off easier. Which is why we're never going to get done because the smaller planets like Mercury has lost its atmosphere.
Mhm.
It didn't have enough gravity and the lighter elements floated away. Alrighty. I had another example of the amount of oxygen and the 18,000 feet. When I gave birth to my second child, somehow I guess I wasn't eating enough iron in my diet. And so I was after giving birth that day in the hospital, I was feeling really light. And the doctor came in and he said, "Are you feeling lightheaded?" I said, "Yeah, yeah." He said, "Well, you're walking around at 18,000. I said, "I am." And he said, "Yeah, you need to," and he prescribed iron.
Oh, for the hemoglobin, yeah.
Yes, because evidently I didn't have enough iron in my blood.
Mhm.
So 18,000 feet, half of the oxygen you should have.
Wow.
Now, the amazing, in this modern day of astronomy, they're looking for life everywhere. Is ice buried in, microscopic life buried in the ice in Mars? Or what about that ocean on that moon of Saturn underneath the ice crust? There's an ocean, a salty ocean that's slushy and liquidy. Maybe there's life down there. I'm sure you've all seen a picture of the Earth from space, labeled the blue marble. What are we? 70% water, ocean, basically? We're really a water planet. We don't think about that. We're not fish, so we don't think of it that way, but it is. If it wasn't for water, H2O, 2 hydrogen with 1 oxygen, we would not have life on this planet. Nor would we have much in the way of weather.
Is the amount of water changing that we have? Is we have the same amount, but it's just polluted? Or is it just gone? Is it disappearing? Some of it?
I would say we are basically a closed system. So not that you can't, once upon a time, there was no water on the planet 5 billion years ago. So it fluctuates, but at this point in our lifespan or a million years, it's probably fairly constant. All righty. Now the amazing thing about water, without going into too great a depth, oxygen exists as a pair when it floats around in the air. And hydrogen is usually hooked to something, 1 H to something else, or 2 H's to something else. And because hydrogen easily loses one of its electrons and becomes a negative little thing spinning around. And the oxygen has 2 extra, let's see, it has a positive charge of +2. And so through chemical reactions, usually they can hook up together to form water, H2O. Now let's look what an ice crystal looks like. This is, okay. So here we have our hydrogen And because of the charges, and we all know a magnet, if you have two magnets, the positive end is going to clunk onto the negative end. They will arrange themselves in this beautiful hexagon, whole series, and it keeps going and going and going. Six-sided figures. Now, I was thinking when I was going through this in my head this morning, a child, almost all children are curious. And I'm sure there was a time when there were 3, 4, 5, first big snowstorm early in the season. It wasn't too cold, great big flakes. They're out there with their navy blue mitten and the snowflakes are landing on it and they're looking at it and they're so beautiful. Can we see a picture of the snowflake? Did you get snowflakes?
No,
Oh,
you didn't ask for.
you didn't
snowflakes.
ask. Oh, okay. Sorry, guys. Next time we'll have some pictures of snowflakes. I'm sure you've all heard there are no two snowflakes alive in the world ever. They're all different, billions and billions and billions and billions of them. But they're all more or less excited one way or the other. Now, a curious child is going to say, Mommy, look at that. Why do they have 6 sides? And if it's a precocious child, they're going to say, why is it a hexagon? Anyway, science is what goes behind your observations and tries to understand why. Why? And now once, and it didn't happen until the 1800s, that scientists began to understand the makeup of atoms and molecules and their protons and their electrons and their neutrons and what that all meant and how they hooked together. And then it became obvious that water changing to ice created a pattern like a hexagon, a 6-sided figure. So snowflakes, which are ice, are 6-sided. So I can get excited about that because I was a scientist once upon a time, and I'm still in my old age annoying everybody by saying why, asking questions. Okay. Now, the thing with water that is, well, okay, matter, stuff, exists in 3 states. It's either a solid, like this table, it's liquid, like this water, or it's gas, like the air around us.
Gas is also called a matter.
Sure, it's matter. Yeah,
Oh, I didn't-
3 states: solid, liquid, gaseous, a gas. Now, each material has a different temperature at which it changes from one to the other. And since we're talking about water, we all know that if I stick this in a freezer and it gets down to 32, it'll change to ice. But if I stick it in a pot and boil it at 212, it'll change off to a gas, and vice versa. So any change of state involves energy. Either it's using energy or it's giving up energy. And this is one of the reasons we have weather. Now, I had to actually go to the dictionary, which I hardly ever do. Sometimes I just have Rima do it for me. But anyway, I went to the dictionary because I couldn't remember which was which. Let's start with ice. You apply heat, it changes to water. More heat, and it goes to vapor. This is called an endothermic reaction. Heat is being absorbed by the material. And if we looked with magical eyes inside that block of ice, we would see all these water frozen molecules, crystals, vibrating, but they don't have that much energy because they're cold. More energy, it's hotter. They move faster. You reach that magical 32 degrees and there's enough heat energy, they break their bonds, the crystals fall apart, and we have liquid water, which is floating around in its container. Or if there's no container, it runs off the table to sea level. Alrighty, more heat. They go faster and faster and faster, and finally They go at 212, they escape into the atmosphere, become gases, which once again, they're further dispersed. So that's an endothermic reaction because it's needs heat to produce the end result. But the opposite happens, we're always going back and forth on this earth, so if we start with that water vapor, steam, say you're boiling water. Have you ever stuck your hand over the spout and got a steam burn?
Oh, yeah.
Why is it worse to have a steam burn than to stick your hand in the 212 water?
I don't know, it's more of a surprise, I think.
No, it's because of an exothermic reaction. It's giving up heat. So as the vapor, which is very energetic, condenses in the cool air around it to water droplets, it's giving up heat. So that steam could be 500 degrees Fahrenheit,
it's
not
hotter.
212, like the water.
My ninth grade teacher insisted all the time throughout this year, you can't see steam, or you can't see steam, that's right. You can see
Well,
water vapor, but you
but-
can't see steam.
Ah,
I'll never forget that.
Well, that's good. See, I'm sloppy. I was using steam in the water vapor that you could see,
Interchangeable.
interchangeable, and you're right. I shouldn't have. Although I'm not really sure what the
But that's
definition of
probably
steam
the-
would be.
I remember from the day.
We should look up steam when this
Was
program's over.
very, very insistent on that,
Okay,
because we always called it steam when you'd see the
yeah.
water vapor coming off a pot of boiling.
but that's like a cloud condensing. It's what you're seeing are the water droplets.
Yeah,
All right, so we go from the vapor by taking out the heat, ouch, and it becomes water droplets in this case, and it's enough, it'll make a puddle. And you keep on taking out that heat, and you wind up with ice, which is why in gardening, when they say there's going to be a frost, you spray your garden with water, because oddly enough, if that water freezes overnight, it's going to give off some heat in doing it, and save your plants from freezing if it's right there at 32.
yeah, they do that to the citrus trees in
Yes.
Florida.
Right.
That's
Yeah.
why the orange grows when it's
Yeah.
gonna freeze.
And that's so thermic, gives up. All righty. Back to the wet thing. So as our air mass, however big it is, maybe from here to Chicago. What am I doing? Okay, as that air mass cools, a couple of things are going to happen. The vapor that's there, the gas, if it cools enough, will condense to water droplets. And if it keeps getting cold, it'll turn into ice crystals. In other words, clouds, either rain clouds or the high cirrus clouds that are made of ice crystals, which I saw this morning, by the way. Ready. And then an air mass that's warm, everything's in reverse from that. So, gosh, what time is it? I think I'm taking way too long.
No, you got plenty of time.
Do I?
Yeah, you have almost half an hour.
Good, because I'm halfway through. All righty. Precipitation. What other pictures do we have here? I'm forgetting.
We have
Let's see what we have.
sky and the sky.
Okay, let's hang on to that a minute.
that.
I think that's later. All righty. Let's read about precipitation. I think, okay, once again, for us, water, it's 32 to freeze and 212, which if we were on the metric system, it'd be 0 and 100. I'm just going to pause for a minute
Easy
because
to
a lot of
remember.
people don't understand the metric system. We have 3 measurements in America. We have temperature, which is centigrade. We have which is gallons and quarts and pints, etc. And we have weights, pounds and tons, all which have nothing to do with one another. Mathematically, you could find a ratio proportion, but it would be weird, not simple. The whole metric system was set up So that, let me think if I can remember. The unit of weight was a gram. I'm guessing that's about the weight of a raisin.
Oh, that's a good,
And 1 gram would occupy, if you had a little test tube, I think 1 millimeter of volume. And at sea level, it would be 0 degrees centigrade. So if they took a milliliter of water and had it at,
no. That'd be freezing.
well, just above freezing, then we got to check that. But those three things, the volume, the weight, and the what was the other one? Ta-da.
Temperature.
Temperature, were all related.
Okay.
Which made conversion from one to the other very simple.
Yeah.
It's like our $100, $1 dimes, pennies
Right.
kind of thing. Much easier than what did the Brits have with all their shillings and whatnot?
Pounds and.
That was weird.
Pens,
Yeah,
Yeah.
yeah,
Tuppence.
right. So anyway, we don't.
Guineas.
So if it's above 32 Fahrenheit, it rains usually, right? And we have a bunch of names for the rain. What's one rain category?
Oh, I can't think, sleet,
That's not rain.
oh,
How about drizzle?
okay.
The list. I came up with a new one after coming back from England. You know, we have a mist, right? Then we have a drizzle. What if we have, sometimes there's something in between, and I call it a mizzle.
Oh, that's good.
So yeah, so I'm gonna be famous for naming a new form of rain,
Yeah,
size.
so fog is a form of rain,
Um,
no?
See,
it touches the ground.
you can certainly get wet from it.
Yeah. Well, through a cloud too, if you sit on the airplane's wing.
In Hawaii, they call the fog near the volcanoes Vog with a V.
Okay,
It's volcanic fog.
okay. I think when we go to clouds, I'll have a picture of that. And it has another name already. Okay, Dan, and if everybody's listening to this, homework, look up where did the expression "it's raining cats and dogs" come from.
Oh, I've heard that and I don't remember.
Okay. Well, you can
Toad strangler.
toad strangler.
Toad strangler. Raining
Really
really.
good one.
Yeah.
Gully
We're-
washer.
A gully washer.
Sure, yes, another one. All righty. What else on rain? Nothing more for now. Snow, if it's below 32. And then I don't know if you've noticed, when it's like 27, 28 to 32, pretty high, just freezing, the flakes tend to be big and fluffy.
Yeah.
The colder it gets, the smaller the flakes get.
Yeah.
Okay. And of course, we've all heard of how the Inuit had many, many, many names for snow. I used to ski and I had a box of wax. I think there were 6 waxes in the box. And depending on the condition of snow, you would wax your skis. Now, all I remember is there's dry, fluffy snow and there's wet, coarse snow. I don't remember all the subtleties in between.
Huh.
So I would never pass the test up in the Inuit culture.
Well, one I know is powder.
Well, that would be dry and fluffy,
Yeah.
I would think. Yeah. Okay. Let me see. Follow my thing down here. Okay. When we have snowstorms, what do we call, you wake up in the morning and there's like just an inch everywhere. There was no wind. What do we call that kind of a snow?
Frost.
A dusting?
Light. Oh,
A dusting?
dusting. Yeah.
Okay. When my daughter was in college at Buffalo, they had a phrase, you know how we say I'm snowed under? They had a phrase called I'm dusted. Okay, I don't know exactly where that came from. Anyway, then we have a blizzard. Now, I actually looked that up in the dictionary this morning because I thought I remembered the definition meteorologically, but it didn't seem harsh enough. As I recall, a blizzard has to have a 6-mile-an-hour wind and
6.
That's what I was thinking.
at least 6 inches of snow. I always think of blizzards as more,
Yeah.
and winding up with more snow. And I think it has something to do with visibility also. I don't know if it's a half a mile or what, but usually when there's a good wind and a good snow, usually a finer snow, that's called a blizzard. Now, I remember because my grandmother was 16 years old when in 1888, can you believe that? Came to America as a 16-year-old to live with her father and uncle and take care of them as a cook and housekeeper and whatnot.
From what country?
Germany. And she came early in the year or at Christmas time in 87 or something. And in March of 88 was the famous 88 blizzard, the blizzard of 88. And there's a book about it in the Hornell Library. And I remember my grandmother saying, now I'm not sure. I suspect it was a northeaster. And we'll talk about that later when we talk about certain kind of weather patterns here. And if that was the case, the wind was coming from the east in New York City, coming off the ocean and coming out of the east. If that was true, much of New York City is a grid, north, south, east, west. My grandmother said all the avenues, they're the ones that run north, south. On the west side, the snow blew up to the third floor of the tenements. The people on the first and second floor had to go upstairs inside and crawl out the third floor windows. Whereas the other side of the street, there wasn't much snow. The wind was so bad. Yeah, isn't that amazing?
But once you climbed out the window,
Then
would you fall through the snow?
no, because
Oh, okay.
when I first moved here, that reminds me, my house was protected by a windbreak of evergreens on the north and the east side. And every winter in those old days, before warming, the fields to the south and west, the snow would blow into those evergreens. And behind the house, it would be 12 feet high and packed. My cat would run right up it. So those days are gone. We don't have that kind of snow at all anymore. Alrighty. So, okay. What else about snow? Nothing else yet. Alrighty. Sleet. Now here's what, does anybody know what sleet?
Frozen.
Icy rain.
Okay, what happens is normally heat rises. No. That's misleading. Let's simply say the higher up you go from the surface of the earth, the colder it gets.
Okay.
It's always colder up in the mountains. It's like on any average day, it's 6 degrees cooler here on my hilltop than in Wellsville, or just because I'm 1,000 feet higher. However, because of weather patterns and air masses that move, and we'll talk about that also in depth later, sometimes a warm air mass gets caught over a cold air mass on the ground. So it might start raining up here where it's warm, above 32. And the rain is happily falling down and hits that below 32 level. And all those little raindrops freeze. And that is what is sleet. Which bounces. So
Right, it
anyway,
becomes hail, doesn't it?
No,
When it gets chucked up and then.
no,
Different.
hail's totally different.
Oh.
Sleet comes in the wintertime. Hail comes almost always in the summertime. And we'll talk about it.
Know that.
Yes.
Sleet is in the winter, is that what you said?
Yeah.
And hail is in the summer.
Yep, almost always. I
Yes,
like
this
to
year.
hedge by saying 90% of the time. And, I've studied lots of different sciences, and it seems to me, well, they're all complicated. The deeper you go into trying to understand what is going on. But meteorology is very, very, very complicated. And there are many, it's like weaving a tapestry, and you might have 100 threads of different colors, and you want to put them all together to make a picture. The daily weather. It's not easy to do. And until modern times, the last 30 years, say with computers,
I think the weather forecasts are worse than they were when I was a kid. I think people back
No.
then knew more.
No,
Or maybe they paid
no,
more attention
no.
to nature or something.
No.
I go like this past weekend, last Friday we were talking.
Mhm.
Was it Friday? You were gonna go home and hang your clothes out.
And you, you
The next day was gonna be nice. And
drizzled.
They did it drizzle or mizzle?
And one of the both. Okay, Regina, here's the problem, and everybody falls into it. Whatever our personal experiences or our memories, which aren't always accurate, come to the forefront. But what science does, it sits down and it keeps a written record. And so they know, probably for the last 50 years, what, on day one of 10,000 days, whatever, how accurate was that weather report? And they have all those records. And we are much better off, on the average, getting it right than we did wrong.
see, I think my uncle knew better weather forecasting than I see on TV and stuff. He's an old farmer and I think he just had, he'd look at the weather reports, but he could interpret them different or something. And he seemed to always know, and he was always right. I was always amazed with that.
You don't believe that, Regina. I really don't believe that.
Yeah.
You remember when he was right and you forget when he was wrong.
And I'd think it'd be rainy and then he'd say, no, it's gonna rain or it's gonna be sunny tomorrow. And he'd be right. And I'd be looking on the computer and
Yeah,
see where it'd be cloudy or something.
but I still think you forgot the days he was wrong.
Yeah,
Yeah.
maybe.
Yeah. Well, you can go, that's your homework assignment for the next 2 weeks. Go find the records of accuracy. They are very good, usually. I'm going to say 95% of the time, they know what's happening tomorrow. 90% the next day, 85% the following day. They're very good at 4 or 5 day forecasts now.
Yeah, the weekly and the 10-day.
But they're still much more than they used to be.
Yeah. The trends maybe.
Okay, and sometimes I don't have it on my whatever program, but we should argue about the woolly bear.
Wow.
Yeah, okay.
I have a friend in Indiana and I would talk to her frequently 3 or 4 years ago. And whatever her weather would be, we'd get it the next day. Impressive. I'd say, what's the weather like? And then have that. And system.
At night you can pick up certain radio stations like WHAM, I think is from Louisville, Kentucky, near where I used to live. Okay, Chicago, I forget what Chicago is, but you can get them at night too. And Wheeling, West Virginia. All of those folks are to the southwest, west, and west of us. This whole idea, and we'll talk about it in a couple of weeks, about air masses moving and bringing with them a certain type of weather. And they move at about 30 miles an hour. So what Buffalo gets at 7 in the morning, chances are by 10 in the morning, if it's starting to rain there at 7, it'll start raining by 9. I'm not talking about thunderstorms, but big fronts moving through. So once again, your friend is Chicago is about 24 hours away, 700 miles.
Northeast Indiana.
Yeah.
Still, I was amazed by that.
Yeah. Okay. Let me see. Before we move briefly to hail, but we're not going to talk about it much because it's going to be later with clouds, is what the Canadians call a silver rain. We call it a black ice or a freezing rain. I cannot remember the date. Do you remember the dates? It was a good 20 years ago, I think. A huge freezing rainstorm hit Quebec and part of Ontario and northern New York. And Montreal had 4 major transmission lines coming in from the power plants. 3 of them went down. And so they were like on bare electricity. Thousands of chickens died within 5 hours because millions of chickens, because they lost their electricity, their fans, and the poor things choked to death on the ammonia because they're crowded,
Oh, I thought it was the heat.
no, it was the ammonia, they choked to death. And then the Amish had to come in and milk the cows and this went on for weeks before they could get their electricity back up. Do you remember that?
I don't.
Is that when there was an ice storm here?
No, it didn't come down here. It was up in the Adirondacks.
Oh, I remember hearing something.
Yeah, well, it was about 20 some years ago, and I listened to the Canadian radio station all the time, so it was a big deal. So I thought the French word silver rain, because the rain fell and
It
froze.
sounds so pretty, doesn't it?
Yes, it does. By the way, I think freezing rain, which means the ground or the surface, the wires, the roads are 32 or below, but the air above, a warm front has come in and it's raining. And then it instant freezes and you don't see it, especially on the sidewalks and the roads. And that's what also builds up on your trees and causes all the branches to come down if it gets thick enough. Alrighty. And finally, which we really won't talk about it, but hail happens almost always in the summertime when you have those big cumulus clouds piling up 50,000 feet into the sky, and then they get dark and they start to rain, but because they're falling through an icy zone, the water droplets change to, what's this one?
I was just thinking maybe people could see, kind of visualize where everything's going up. So
Well, I don't, anyway, we're gonna talk about it later on, when we talk about weather, and clouds. But basically what happens at raindrop, because these cumulus clouds are huge convection conveyor belts with hot air rising, cold air sinking, and they set up this conveyor belt. This poor little raindrops happily fall into the ground and it's caught in the draft. Another coating of ice on it.
okay.
Again, depending on the violence of the thunderstorm and the speed of those currents, it can go round and around, and every time it goes round, it gets bigger.
Okay.
So if you slice a chunk of hail, this looks like an onion, rings. So anyway, more on that later. How are we doing on time? I gotta talk about humidity.
Got 3 minutes.
3 minutes. Oh dear. Oh dear. Well, we're gonna have to carry this over into next time because it's on. Let me just see. Well, very, very briefly then, maybe we'll run over it a minute or two. Humidity is that muggy feeling we have. What it is the amount of vapor in the air. And then what's interesting is that warm air, we won't go into the details now, will hold more moisture. A given volume. The warmer it gets, the more moisture it can pick up. And vice versa. If it cools down, it can't hold as much moisture. So 100% is 100%. So at a given temperature and pressure, there's only so much moisture that can be held as vapor. There's sometimes you can trick it, but we're not going to talk about them right now. Something called the dew point, and it does have something to do with dew, is the temperature at which the air can no longer hold any moisture as vapor, and it begins to precipitate out or condense out as either water or ice, depending on the temperature.
So that's the dew on the ground.
On the ground or the frost, depends on the temperature. And it's also what makes clouds, because you have an air mass, say in the summertime, the sun comes up, starts warming the ground, warms the air, begins to expand, gets less dense, begins to float up like the helium balloon, up, 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 until it reaches the dew point up there somewhere. And then clouds begin to form. Or ice if it gets high enough. Now, human beings, fortunately for us, somewhere along the line, evolved these sweat glands, which allowed us to live in the tropics. And which is why people say, oh, I'm 90 degrees in Phoenix, Arizona, but it just feels hot. Here, 90 degrees, oh my God, it's just drag around. Well, what's going on? It's 90 degrees, 90 degrees. What's different?
The amount of humidity in the air.
The humidity, it's dry, and therefore the evaporation evaporation of our sweat is efficient,
Mm.
and wet going to vapor cools you down, exothermic, I think. And here, the more muggy it is, the less efficient our sweating is, and we just feel, oh.
Yeah.
So to wrap it up, if you're a gardener, you get up on a sunny day and you look at your thermometer barometer and it's 70 degrees already at 9 o'clock in the morning and the humidity is 90%. Do you go out then and work in the garden, or do you wait until the afternoon when the temperature's gone up to 85, but the humidity has dropped to 70? I'd wait till it's hotter, but less humid.
Yes.
Okay. Let's see, is that my end? Might have to be my end. No, we didn't get to air pressure, but we don't have time. So next time, what are we going to talk about next time? We're going to pick up where we left off about air pressure, the third thing that affects our weather. And then we're going to talk about the overview. We're going to go up into space and sit in the shuttle and look down at the Earth and figure out why it was always hot and muggy down in the tropics and cold and dry. As a matter of fact, North Pole is a desert. We don't tend to think of it, but it is a desert. What are the doldrums? That's a word that we've taken to mean something emotional, but really meant something scientific. Did they really throw the horses overboard at the horse latitude?
Yes.
Yes, she says. All righty. And what else?
Because the air was not moving.
Right. Well, we'll find out why. And we're going to look at some, I think we're going to look at some climates also. Because in certain parts of the world, depending on what the atmosphere is doing, we have certain kind of climates, like a desert versus the jungle. Yeah. So Rima, thank you. Yeah, that became
That,
here. Are we still on?
yes.
Guys, if anybody's listening, I've read lots of up.
There we go.
There we go. So one of the books out this week. Just bought these. I've read lots of books on the weather. I've studied the weather for a long time, but you have to get organized. You have to sift through and organize. And so I bought Peterson's guide. And as everybody who knows me knows, I don't often give out A pluses. I'm going to give out an A to this. Don't buy the paperback. To save a tenth of a penny, that 0.1%, they make the market too small, so it's hard to open the book without breaking the binding to read the inside letters. But otherwise, it's a well-organized book. And of course, you can read a book from 30 years ago, but because of satellites and the view from up there, we can picture so much better what's going on down here in the troposphere at sea level, well, on the ground where we live. So anyway, get the hardcover. I'm done. Thanks for coming.
Thank
Regina.
you.
Are you going to be at the bird club tonight?
Yep.
Yep, me too.
Yep.